If you put an ice cube in your room, the ice cube absorbs heat from the room. After it melts into water and you take it out of the room, the heat from the room is essentially carried out with it. This is actually the basic principle behind how air conditioners work. Air conditioners don't really produce cold. They're just movers of heat. The reason you feel cool in an air-conditioned room is because the heat in the room has been carried out by the AC. But the medium air conditioners used to transfer heat isn't water. It's a much more efficient substance called a refrigerant. One of the earliest and most well-known types of refrigerants is Freon, which became a sort of synonym for refrigerants. Refrigerants have several thermodynamic advantages. They evaporate and condense easily, absorb heat efficiently, and are generally safe and stable. Now, let's take a look at how an air conditioner actually works. Inside an AC, there are four main components: the compressor, condenser, expansion valve, and evaporator. The compressor and condenser are typically outside the room, while the expansion valve and evaporator are located inside. Refrigerant runs through copper tubes that connect all these parts. The refrigerant starts as a low-pressure gas, with a temperature of around 41 to 50 degrees Fahrenheit, 5 to 10 degrees Celsius. It first enters the compressor. As the name suggests, the compressor compresses the refrigerant. When compressed, the gas shrinks in volume. Its pressure skyrockets, and its temperature jumps to around 176 to 212 degrees Fahrenheit, 80 to 100 degrees Celsius, or even higher. This follows the basic principle of physics. Pressure and temperature are directly proportional for gases. When you compress gas, both its pressure and temperature increase. Reduce the pressure, and the temperature drops. If the refrigerant is like the blood of the system, then the compressor is its heart, the most crucial and most expensive part of the air conditioner. Older AC models used piston-type compressors, which work a lot like a car engine, using up and down pistons to compress gas. But they were noisy and inefficient, so they've mostly been phased out. Modern high-end air conditioners use scroll compressors. They're much quieter and more efficient. A scroll compressor has two spiral-shaped scrolls. One stays stationary, while the other orbits around it. Gas enters from the outside, gets trapped between the scrolls, and as the moving scroll rotates, the gas is gradually compressed toward the center, where it's discharged as high-pressure gas. After the compressor turns the refrigerant into a high-pressure, high-temperature gas, its job is done. Next, the refrigerant flows into the condenser. The condenser looks like a row of dense metal fins, with a fan blowing air across them. This helps the refrigerant release heat and cool down. The gas, now at around 212 degrees Fahrenheit, 100 degrees Celsius, starts cooling and condensing into a high-pressure liquid. At around 86 to 104 degrees Fahrenheit, 30 to 40 degrees Celsius. This part might seem simple, but two key physics principles are at play. 1. Heat always flows from high temperature to low temperature, and the bigger the temperature difference, the faster the heat transfer. That's why the refrigerant needs to be super hot, so it can release heat efficiently. 2. A liquid's boiling point depends on pressure. The lower the pressure, the lower the boiling point, making evaporation easier. Higher pressure raises the boiling point, making condensation easier. Since the refrigerant has been compressed, its boiling point is higher. So now, just releasing a bit of heat is enough to get it to its condensation temperature. It condenses into a liquid and releases heat, which is why standing near the outdoor unit feels like standing near a heater. But keep in mind, the refrigerant is still at high pressure and now a liquid, just not as hot as before. Next, this high-pressure liquid refrigerant travels through pipes to something called an expansion valve, a device that reduces its pressure. Common types include capillary tubes, electronic expansion valves, and thermal expansion valves. Let's take the thermal expansion valve as an example. It has a tiny nozzle that restricts the flow of refrigerant, with a needle inside to control how much comes through. As the liquid shoots through the narrow valve, its pressure drops sharply, and part of it instantly evaporates. Because again, pressure and temperature are related. When pressure drops, the temperature also drops. That 86 to 104 degrees Fahrenheit, 30 to 40 degrees Celsius, liquid suddenly becomes a low-temperature, low-pressure mixture of liquid and gas, below 41 degrees Fahrenheit, 5 degrees Celsius, with a low boiling point, making it easier to evaporate and absorb heat. Now the refrigerant enters the evaporator. It's another set of tightly packed copper tubes with fans blowing indoor air across them. The refrigerant absorbs heat from the indoor air, evaporating into gas in the process. The cool air you feel? That's heat being removed from the room. At this point, the refrigerant is again a low-pressure gas, at around 41 to 50 degrees Fahrenheit, 5 to 10 degrees Celsius, ready to be sent back to the compressor to start the next cycle. So how does an air conditioner automatically control the temperature? That brings us back to the thermal expansion valve. It has a temperature-sensing bulb at the evaporator outlet, filled with the same type of refrigerant. If the outlet temperature rises, the refrigerant inside the bulb evaporates and its pressure increases. This pressure is transferred through a capillary tube to a diaphragm, which then pushes the needle valve open wider, allowing more refrigerant to flow through, so the evaporator can absorb more heat. If the outlet temperature drops, the valve narrows to reduce the flow. This creates a dynamic closed-loop control system that keeps the refrigerant in the evaporator at the optimal level. Enough to cool, but not too much. So really, air conditioning is just about creating pressure and temperature differences, using refrigerant as the medium to carry heat from inside the room to the outside. That's how air conditioning works. Do you get it now?